Hello and welcome. Today I want to talk to you about this element. This is called 7 segments display and it was used some time ago to display some numbers, some symbols. Eh, in order to understand how this works, we need to understand the insides of this element. So first of all, you need to understand that we may be able to produce LEDs in a lot of presentations. They can be small, they can be really big, they can be square, they can be in a line like this. Actually, nowadays on your cell phone screen and in your television screen we got plenty of these LEDs. Nowadays the monitors on your cell phone, on your TV are made of LEDs. So we can produce LEDs in a lot of presentations. In particular, we may be able to produce rectangular LEDs and then we may be able to put these LEDs in this kind of arrangement. So inside of this we got seven LEDs. Actually we got 8 LEDs because we got the 7 segments we use it to display symbols, but we got an extra LED used as a dot. This dot can be used to represent decimal values, but also we use this to identify the proper orientation of the element. It's not the same display the symbol like this and like this. So thanks to this little one we are able to identify the proper orientation. So inside of this we got 8 LEDs like this. And if you remember, all the LEDs have a polarity. They got a positive connection called anode, and they got the negative connection called cathode. So in order to reduce the connections required to power the 7 segments display, we get some connections together. We may be able to get all the negative connections together and then we call this common cathode 7 segment display because we got all the cathode together, all the negative together. This is an example. This is a 7 segment display, and if you see, all the negative connections, all the cathodes are connected together. So we provide negative power here and we just need to provide positive connection to any specific element of the arrangement to display a symbol. Again, we may be able to get the anode together, all the anode from the LEDs together, and then this is called common anode 7 segment display. As you can see, this is not, this is it. This is the positive connection all together. So we provide positive connection here, and then we need to provide a negative signal in the independent connectors of my display. So something really important, we need to identify the number or the model for my 7 segment display, because this way we may be able to identify if this is a common cathode display or common anode display. So this one is 5611BH. Then if we look on internet for this model, we may be able to identify that this is a display with all the positive connectors together. So to the connection number 3 or the connection number 8, we need to provide positive, and then from the connection 1 to connection 10, excepting of course 8, we need to provide negative connection in order to activate the elements on my display. So something really important, remember, we need to provide a resistance to restrict or to limit the current through the LED. This is my LED. I got power from my Arduino, positive, negative, and positive, negative to my breadboard. If I put the LED directly to the power, I may damage my LED because there is no restriction on the current through this resistance, and I don't want that, right? Because that may damage my element, and of course I don't want to damage this little guy. I need to provide a resistance in a serial way to restrict the current. So I got from negative, I got my famous 330 ohms in this connector, brown connector, and then I got my positive connector here. So let me provide power to the card. I put the positive connector to the long leg of my LED. This is the long one. Here it is. And then when I provide negative connection, it turns on. That's it. Remember, I use this resistance to limit the current in this element in order to prevent any damage. If I put this directly in the breadboard like this, I may damage it, and I don't want to. So this is made of LEDs. Then again, we need to limit the current on this element. So I got my positive connection. Remember, this element has all the positive connections together in connector number 3 and connector number 8. And that's why this dot is useful, because let me show you another diagram. Okay, I got it here. No, it's here, this one. This one is the useful. Let me make it bigger. Thanks to this small dot, we are able to identify port number 1, 2, 3, etc. So from the dot in the opposite side of the dot, it's the first connector. So this is 1, this is the port number 1, this is 2, and this is 3. This is the common connector, and then I'm going to provide positive connection to the common connection, like this. I hope you can see this. This is the dot from the opposite side, the first one, the second one, and the third one. So let me put it back. And then we may follow this order in order to check the position of the elements. So port number 1 should be the element A. So if I provide power to port number 1, this one, remember, in the opposite side of the dot, this is number 1, this one should turn on, as it says in the diagram. So let me put it, and there it is, A. Then port number 2, it's for the D element, Let me connect port number 2. Sorry, this went off. Port number 2, and there it is. D. Port number 4 should be C, should be this one. There it is. And port number 5 should be DP. DP is this dot. So there it is. After that we got V, this one. So let me change my hand. That's it. V. The next one it's A, this one. A. Then F, and finally G. So F and G. I hope you can see. Yes, it's clear, I guess. F and G. Okay, this one not. There it is. F and G. And that's it. So now you know we got LEDs in here. We need to turn them on in order to display symbols. Something really important, we need to use this resistance in order to restrict the current in the LEDs as always. And then we got two options. We can provide resistance to the independent ports, something like this. Let me show you. This is the resistance for my element E. Then I need to provide the resistance for the element D. Then again for C and the P and so on. So we need to provide at least 7 resistance to limit the current through the 7 LEDs in my display. But also we may be able to provide only one resistance in the common connection. This way we can save elements, we can reduce the number of elements, because if all the LEDs are connected together to the same point, if we restrict the current to this common point, we save or we reduce the number of resistance we need. We can do this, yes, of course, but be careful. The 330 ohms value was calculated for a single LED. If you want to restrict the current on 7 or actually 8 LEDs, we need another value for this resistance. We need to do the maths. I'm not going to do the maths here. I'm going to create another video and I'm going to explain this, because we need some circuit background, Ohm's law, etc. But it's quite intuitive. The 330 ohms alone, it's not enough to restrict the current connected in the common connection for all the LEDs. It might work. Actually, you may be able to identify some circuits with a 330 ohms connected in the common element. And it is going to work. It's fine. It's going to work, but this is not correct, and this is not the efficient way for doing this. If we do the math, we may be able to identify that using only a 330 ohms in the common connection may spend more energy. Your circuit may spend more energy than the energy you need. This element is going to dissipate more heat, and then your circuit is not going to work efficiently. It might work, yes, but not efficiently. And then if you design a circuit to work on batteries, you may reduce the time life or of your battery, because you don't use the proper resistance value. So for a short circuit, or actually for a short experiment, using only a resistance 330 ohms in the common connector, it's enough, it is going to work, but it's not correct and it is not the efficient way. If you want to understand this in a more detail, you can check the specific video for this on my channel. And I guess this is it. I hope you enjoyed this video. I hope this was useful for you. And please don't forget to subscribe to my channel for more videos like this. Bye bye.